Welcome back to Cloud Computing and Big Data, Lecture 9, our second part. And Lecture 9 is about Platform as a Service. And in the first part, we discussed a little bit already with a reflection in mind that it is very close also to Infrastructure as a Service, the overall idea of having a Platform as a Service. The first part started a little bit with the idea also thinking back of MapReduce for one, let's say, a couple of users maybe in the machine learning regime, or as we have seen using maybe also data analytics technique, HD Insight and all the kind of basically MapReduce engine might be very much a platform to do sophisticated machine learning applications, using then the outcome of the machine learning for more advanced applications, software. So very on the top of the stack, if you want, on all of this. But for some of the infrastructure, let's say administrators, for people that working on the infrastructure field, you would say MapReduce might be even, let's say, an application of the infrastructure. So we're talking about the infrastructure being rather just the hardware in terms of CPUs, GPUs. Is there any storages, concrete, let's say, disks somewhere, maybe a tape archive even. And then you have all the interconnect, the network that we don't discuss so much in the course, which is equally important. Of course, this is something I refer to the network course we have at the university, where this is basically much more covered in much more detail there. But these are sort of the ingredients as the infrastructure way. And then when it starts to be interesting to understand where's now the overlap, or where's basically the smooth transitioning, if you want, to the PAAS level, this would be really virtualization. Right? That's where it starts, where you think about, okay, virtualization is a layer, abstracting from the physical hardware, as we also discussed in lecture 4, enabling now also that, that different users can share basically the physical hardware. So this is a time where you then can think maybe it becomes more and more a platform, especially then if you talk, for instance, the AMIs that we have learned from AWS, the machine images, which are already fueled with cutting-edge deep learning stacks, right? Pre-configured, ready to run. And there you can see this is already a very nice deep learning platform for application developers. So in one respect, you would say the PaaS and infrastructure as a service that we had the last time, so the IAAS, the PAAS, are really very smooth transitioning into each other nicely. And the concept that really brings them together is the virtualization, really, and then the idea of using this with applications. So another important part is that, of course, the what we had also then alluding to in part 1 of lecture 9 here is there's this interesting platform idea of having very different Lego bricks, right? That's the analogy I want to bring here in the course, to really see that there's so many different Lego bricks in all of these different clouds. And we picked the Google Cloud just to make the case for several different applications. And you see the same Lego bricks always came again, the Google Big Table we discussed, bringing us also to the topic of NoSQL stores, right? And part 1 really gave a crash course, if you want, on a couple of slides only, what NoSQL stores are. Normally you would have a whole university lecture series definitively about it, because there's so many different facets on it these days: key value stores, document stores, and so on, and graph-based ones we even will discuss later in the course. But the key message to take away from part 1, perhaps, which is important to take, in your brain, is really these are dealing with information which are not so structured, right? In all of the different cloud applications, even in Facebook, you see that every user has not the same information shared, right? And this is a fundamentally different concept than the SQL relational databases you maybe know from Computer Science 101 courses, the earlier computer science courses, where basically you have schemas. Every table in the schema has certain fields, let's say a name, a surname, a phone number, an email, and tax ID, whatever. And this information needs to be basically filled by everyone. Then SQL is very good. It can have indexes also for quite good performance. But as soon as you start the space of, let's say, sometimes in social media, where people don't have to share everything, right? It's very flexible. You can share what you want. And with this, you have information like 200 different fields. But, many of the users maybe share just 10, but it's also not the 10 same fields they share. Hence, you have very different fields that people share, that people fill, while many others are not used, right? So empty fields, very bad for the idea of, the kind of structured approach. Hence, the unstructured approach with NoSQL stores brings us then benefits in terms of performance, especially if you have this key value structure where you can then easily access it. Like we have seen, for instance, with the key having a website, for instance, and storing information to this website can be one of these key value aspects. Not saying that everything what normally is on each website the same. You see that today, basically, when you go to different websites, many different websites have many different information. So in this sense, lots of interesting ideas how you can use NoSQL stores. Hence, I would encourage you to look at part 1 if you don't have it already here, finding just part 2 on YouTube. Now, part 2 of the course here in the PAAS topic will be going again into the application space, but also a bit more again thinking about developments, right? So in a way, we said also in part 1, platform as a service is for developments of applications. So you can see that with the Lego concept that you have there, you have lots of coding time that you don't have to do anymore. You can focus on your business logic, on your application logic, and you basically build that, and that's the beauty in it, on top of the infrastructure as a service, right? All the Lego bricks you have, for instance, in the Google cloud on the PaaS level, they are perfectly working together with the infrastructure as a service level from Google itself. Hence the scalability, shrinking requirements to hardware, which some also call to basically then the middleware, right, that you would have for your application layer to really abstract from the concrete hardware, and then enables us to scale up and down, for instance, if needed. But then we have also discussed already in part 1 an example of the Google App Engine, right, supporting the whole development cycle. So if lots of development tools, logging, monitoring equally, but also deploying the model then in the app stores, in the, let's say, in the cloud. And then from this, you have a very nice transition process from your development cycle, while you not have to deal with all of the complicated issues now of scaling, right? We have seen in one example, you can easily connect maybe basically a data proc cluster again, which is similar like the HT Insight cluster, featuring Apache Spark for something that your application will need, right? And this gives also what you see here, new development capabilities, right? You don't really add maybe big new stuff and new capabilities. For instance, machine learning, some of the machine learning services, it can be relatively easily used and already, let's say, optimized with default values, with default approaches to basically enable not machine learners to do machine learning. Of course, this is a sort of very explosive thing to say, especially in my respect of the things I said before, right? When we do the machine learning, even in this course, it's very shallow. So hence, I recommend you to a real machine learning course. But you can see that some of the regression techniques, which some people also see is machine learning, are very trivial to put on a time series of data to get, let's say, certain trends out. And if you have regularization and validation as sort of automatic parameters included, you already, let's say, have the basic skills automatically used to combat overfitting, which, was one of the problems we discussed. Has machine learning always inherent, and is one of the major goals of a machine learner to prevent overfitting of data, to make a real statement or an estimate out of basically your data that you have right now. In this sense, there's these building blocks, and when we come later in the course also here and there to some further examples of machine learning in NLP, in different areas of machine learning today, you have seen that not only the Google Cloud, but also Amazon services are following through. So speech recognition, text recognition, building blocks, Lego bricks, if you want, right? So really nicely optimized to work together with your databases you have in the cloud, working together beautiful with the underlying storage that you have and computing capacity on the IAAS level, right? So the infrastructure as a service. So this is of course, nice idea to support if you want the complete application development lifecycle, but also the application lifecycle itself. Hence, you have logging, you have error detection, right? Is something not working well? Is the performance bad? tracing of errors. You have basically then also many different options to increase the versioning of your app, right? Think about the apps, which always have, let's say, different versions. You have to manage all of that. And then there come a couple of things which are also should be highlighted in a way, especially as we go to much more heterogeneous elements. And for this, it means automation is a key. And also thinking about that one development that you do should, of course, be working on many different platforms today, right? So we don't anymore have just a big desktop computer with a nice GPU from the old times and working on a desktop. Today, people playing your app probably on mobile devices, most likely perhaps, right? If you think about Angry Birds again as an example. And then you don't have, if you maybe talk still about the kind of browser-oriented app or something like that you have on desktop as well as multiple mobile platforms today, iPhone and Samsung and whatever. This needs to be also considered. There's not only one browser, there's different types of browsers. And this is also what the clouds these days quite nicely support. So you can easily port these applications. You can develop for multiple, let's say, heterogeneous platforms which exist. And this is, of course, a nice idea as well. It offers you as a developer of apps a bigger market. So you can, of course, then think about not only this particular store, but also the other store is just a couple of small developments really away. So in this sense, you can really think that this is a nice area of work, quite seamlessly working together. And this means also then with the idea of, again, what else would you do, right? You would think maybe then have your own hardware infrastructure, a server that is always there for the app, managing download and uploads in high performance. So we would say there's a sophisticated, let's say, infrastructure and tool set that is something you can swipe your credit card for. And it gives really then, let's say, a small startup the equal chances like in big organization to use then these to, let's say, start an app that might be becoming something like, Angry Birds. As I was alluding to, sometimes you have to look in the history of Angry Birds at these development teams there at that time were also thinking about a soccer game that failed, right? And then they came to the idea of Angry Birds, and then everything lifted up. So, and then they were very successful. Hence, you grow with the demand. And I think still this shows a nicely entry area, because you as a small SME, for instance, you cannot afford all of that. You can hire so many development, let's say, teams that do all of that, because your money is basically very restricted. But you can start small, maybe doing a very specific business intelligence or analytics software for certain trends in retail, whatever it is you do, or an app for games, as we will see also a couple of examples here. You can start small and grow with your demand in the clouds. And this pay-as-you-go model makes also this possible then, and basically then, of course, increasing more and more maybe your users means, which basically stands for this here, right? So basically lots of more users needs lots of more processing. Hence, you also have to increase here with your infrastructure. And this is perfectly supported. And also from the payment model, quite essentially a fair thing, because otherwise you have to do and create your own data center or smaller, let's say, cluster. One thing we also didn't really maybe put in the equation, and this is something which is also the cloud providing very smoothly, is a geographically distribution of development teams. I mean, this goes without saying, everybody can access the Google Cloud. You can see that, well, basically in Europe, everything goes towards the end of the day. Maybe someone, in US is just waking up and can then, contribute further to the development of the app. So it is enabling you with an environment which is automatically worldwide accessible. And with this, of course, the development teams or support teams, let's say, can work much easier, let's say, in a non, let's say, local setup, you would say. Of course, this is very important for larger enterprises, for larger organizations, where really people are in different, let's say, maybe continents even, but you can think already between Iceland and Europe right now are 2 hours differences. And here and there gave some trouble, especially with very early bird meetings and things like that at 8 o'clock, which is 6 o'clock maybe here in Iceland. So think about that. This is all already in Europe here and there with our time zones in Europe. Interesting endeavor. And then one thing also you have to think about that this is perfectly supported from different languages, right? So the Google Cloud, of course, is automatically offering you also several different languages here and there. So in this sense, quite interesting material. We will talk about here in lecture 12 more about some of the aspects I will now allude to as well, because it has relations to how you develop in the cloud. And some of you know that already. It's something about containers. We discussed this in one of the lectures already. So containerized applications are often used. And you see here, the whole idea of the Google Cloud is basically based around this, that you would have different tools to create basically then these interesting containers. But a topic that is so rich that we will devote a complete lecture for it, lecture 12. So I will just go here the overview why it's important as a Lego brick, if you want, again, to have a register, for instance, here for all these containers. But then you have also other, let's say, tools you would have to use here in order to, support really your developments. And you see a lot of things here that in IDE, an integrated development environment, that you can really use to code, right? Something like, Eclipse, for instance, perhaps out of software engineering, out of software development. You have repositories that are all private Git repositories within the Google Cloud that you share with your geographically distributed development teams. So there you can really go ahead quickly, while still, of course, as a private company, you are interested that your things are private, right? You don't put it in a public GitHub, for instance. So many of the things is like debugging, things you already know, hopefully from 101 computer science and software development. Even tools for Eclipse exists. I said to you, the IDE that is quite known in the world, for lots of different plugins. Also, there's also tools for Eclipse. So if you used to use Eclipse, you can work with the Google Cloud as well. And then, task automation, many games, many applications have then different automations of tasks, usually always that follow. And you see again and again different elements here. I will not go through all of that. Visual Studio is basically another IDE that people know you can also use with Google Cloud. Hence, if you have interest to basically build, in the Google Cloud, I would recommend you to look at this more closer. There's a Cloud SDK. You see also quite some support for languages is here available. And for instance, Java, what we teach here at the University of Iceland, I think also in the software development courses, is supported. So coming a bit larger in the context also that this is of course something where in one respect you would say the Google App Engine is quite good in, right? So when we talk about now in the context, again, enabling this as virtualized Lego bricks on top of infrastructure, how we see that, we have several different elements which are a bit unique for perhaps the Google App Engine, like the big table really, which is Google quite known for. Right, and then also the whole App Engine was having this kind of framework to really do web applications, do applications at scale, is quite nicely supported in the Google App Engine. However, we would say that, of course, other vendors here, you see Microsoft Azure and AWS, have also their unique selling propositions, right, which you use, like the S3 interface we discussed, so and so on. So in one respect, you could also see maybe you want to use, also S3 storages in one of your applications combined, then, with other with other App Engine ideas in the Google Cloud. So in this sense, think about always that the world is bigger, and through the S3 interface, of course, there are possibilities to reach out to the REST API. But then you're customers of two clouds. Of course, is perhaps also something to have to think about, different costs apply, and so on. It's important to see that in a way, the Google App Engine is quite good oriented for libraries for doing this in containerized applications. So here is another idea of connecting it to the course when we said, okay, we have deep learning images in the AWS field. We have this AMIs, which are quite nice, which is one way of doing it. So virtualization. But containers have a certain addition, or let's say benefit, in contrast to the virtualization. And of course, that's something I want to talk with you about in lecture 12 much more. And I give you a sneak preview on this, that you see a little bit what happens here is that the normal virtual machine you learned in lecture 4, you would have an infrastructure, you know, this physical infrastructure that you have here is then, you know, coming basically to an end, having a host operating system and a hypervisor that then creates this virtualized view on the real infrastructure, right? So this hypervisor enables us this virtualization layer that we know, so that we could put on one physical hardware, let's say different guest operating systems. They all have their applications, the binaries, the libraries that work for this specific guest operating system. Could be Linux, could be Windows, could be whatever, a Mac, whatever. So what basically then the point is that you always carry around this operating system, right? So that's sort of a big thing. As you know, an operating system today has massive functionality. It has to have much functionality. And the idea is, maybe could we do this with a container runtime a bit more streamlined, right? And this enables us here a little bit what you see here, that there is a, you know, infrastructure with a host operating system that's you already always have, right? There is an operating system you have to have. Otherwise, you can't use really infrastructure. Also not at scale. So there needs to be some specific host operating system. But then on top of it, instead of saying we have this virtualization layer, which enables us, of course, many beautiful things we have seen, and the containers cannot handle maybe all of that, what the virtualization can do. But for specific areas of applications, you can have to have pre-installed applications inside a container. You have the binaries and libraries you needed, and even data already prepared, maybe in these containers. And this is sort of the idea I will allude to much more in lecture 12. So I stop here with too much explanation. But then the possibility is that with having then Kubernetes clusters, which enables us then to work with these containers, as the name suggests, you're pretty nicely containerized in the analogy of Imeskip, maybe, right? Some skip that, you know, it's really sort of a thing that you have a container that comes on a ship, a container ship, which in itself has everything, and you don't really know what's inside perhaps, but it comes with a standardized size in a way, right? So that all the shipping that can be done over the ocean can be done by this container. So in this analogy, the idea is here the same. So the containers could be shipped around by Kubernetes into other Kubernetes clusters, could be going into your own Google Cloud platform, or your own data center, maybe here somewhere in Iceland, or other clouds, because you basically form a container according to the rules. And of course, it is now an implementation element that we call Docker, and that will come in lecture 12, and usually ask in the lecture, is there someone already using Docker? I think usually people say yes, a couple of those. Some people have actually used Singularity and Aptainer, something we also talk in lecture 12 briefly about, which are other solutions for doing containers, but they're also basically interoperable. You have to do a bit massaging if you use a Docker image in Singularity sometimes, or Aptainer, which is a new version of Singularity, but it works. So basically, and it can reduce a lot of work on applications. Hence, and instead of doing an image of, let's say, a virtualization layer that we have used before in AWS, for instance, here you would think about now having a Docker image that has all the necessary, let's say, requirements to pull itself the information needed from the outside, or has already, let's say, everything here, and that's why it's such a small layer, has already, let's say, the recipes, as you would call that, to really have the applications and the binaries pulled from a registry, or basically have already some data inside the container that we can use. And with this, it becomes a very interoperable way of, and a very smart way to build your applications, also preventing yourself a little bit as a developer to the cloud, let's say, vendor lock, right? What we sometimes see is, of course, when you build, like I was alluding to, your platform as a service, usage with all the different Lego bricks to one particular cloud, let's say the Google Cloud Platform, then you're pretty much stuck with it, right? You, of course, stay inside, or you do everything you do with the AWS AMI images. Okay, you go there, you build your other applications around it, use TensorFlow, use PyTorch, that's fine. But you sort of are stuck in this AMI image, right? So you need to have that. So the idea here with the deep learning containers, for instance, that I highlighted here would be if they are really properly done in the Docker image and you put your applications within this container as well, with all the dependencies, all the libraries, you can shift around the container and chances are you can use them in MS Azure, for instance, if they're proper Docker images, essentially. So it enables you, as this actually here suggests, to be a bit, let's say, prevent yourself from the vendor lock. However, talking on the Lego bricks, and all Lego, right? It's a big way of saying there are so many Lego pieces these days. Of course, not all Lego pieces will be fitting with this automatically, right? Here we talk about applications that really can be containerized. If you now use, for instance, APIs from AWS latest services on natural language processing, for instance, you're still bound to these. You cannot really easily put that in a container. You can maybe use the API in an application somewhere, but then it's getting harder to do that because you have an external dependency. In this sense, of course, take that with a sort of care when I'm saying you can ship around your kind of cloud container easily. In some respect, that's true if you have, let's say, some Python code, some Python smart application logic elements which are using machine learning or some deep learning autoencoders, for instance, for doing some specific elements, let it be image analysis of the Northern Lights, and you have an upload and download service maybe of your, within the Google Cloud created for the Northern Lights, and people swipe the credit card or get credits maybe if they upload something. And with the credit card, you have a business model that people that don't upload, that can, of course, download and pay for it. So this is an easy, let's say, way how you could do and think about it, that you would combine this with billing services, but then in the idea of the application logic, really, let's say, maybe annotating automatically the Nordic Lights. Can you understand where they have been maybe, let's say, taken from the images or even from the videos, speaking of big data analysis. So in this sense, there are certain elements where you could think of that this could live in a container while combining it maybe with a couple of things in your applications around the Google App Engine in general. But the kind of real deep learning code can be containerized and maybe also for training put out to your own data center to save costs for training. And then for inference, you take the container back with the trained model back into the cloud and then use it for inference, which are far less costs if you think about the usage of the underlying infrastructure. So, and I could go on and go on. Of course, containers will have a lecture. These days, you would even say it should be part of software engineering in general, I think, containerized applications and so on. And this comes then quickly to our discussion of Kubernetes and Mesos. It's both tools which then enables us to deploy at scale, to go really into the cloud using different nodes and so on. And I will discuss this more in lecture 12. Coming a bit back to the Google Cloud, also for data analytics. So this is this kind of idea that we talked about in the earlier part of the lectures. Not all is considered directly machine learning. Some of the things are rather data analytics. And we have already talked about the differences. And there are several different tools around it. I just give you two that basically already can relate to. The Dataproc is a service that you can almost see very equivalent to the HD Insight cluster, right, that we have seen in MS Azure, but now it's hosted inside the Google Cloud. Of course, it offers you the recent big Apache Spark distributions, also Apache Hadoop, but also the ecosystem is, of course, nicely supported if you talk about HBase and others, for example. The benefit then here of the Google Cloud, of course, you have some other Lego bricks, again, that you can combine, like BigQuery for the data warehouse ideas of business intelligence. So something which is already very optimized towards these analytics. And that's why it's also sometimes in the area of business intelligence. But there you see many different tools. Streaming, we already discussed, right, in the financial sector. streaming tool. So you always have the latest, greatest information from the stock markets or the latest news basically from the companies that influence the stock market. So these are basically all elements that you need as a Lego brick when you work with these areas. Publish, subscribe is a pattern which really offers you a quite nice way of subscribing to specific notifications that you then always get when you publish something. So a specific, let's say, idea of sending messages around, and all of those can be really quite nice here to use. I cannot go in all to them because of the time, but here or there I give you also a little bit the idea that, you know, big players are using this on a daily basis, right? So, and of course, when you go to the website, you see many of these testimonials, because of course this gives also credibility to the Google Cloud. It gives marketing enormously. If a, let's say, third party gives this, right, Vodafone, it's not really you know, Google itself, it's not you, but it's some company you can relate to, that you think, okay, Vodafone has done it, then it must be not the bad service. And they also quantify this nicely. That's what I like in this. You see a little bit here, Vodafone Group moves 600 on-premises Apache Hadoop servers to the cloud. So take this number shortly and breathe, right? So 600 on-premises Apache Hadoop servers. So they had really Hadoop you know, installation in their own cellar in Vodafone, probably also geographically distributed. But there were a development team and administration team that had to deal to keep the 600 Apache Hadoop servers alive. And a couple of them, you know, already are name nodes, a couple of them are worker nodes. And if it's a more advanced model, some of them are just task nodes, some are the data nodes. Remember, the difference was that data is then there to be processed while the task nodes are just computing. But in a way, it doesn't matter. It shows you just that many of Vodafone people there had also be, you know, spending their time, and these were probably experts from, you know, just managing all the server all the time. And they moved this to the cloud to save costs. Now you can say, okay, we have seen that it costs quite a lot, right, for doing this Apache Hadoop servers. Yeah, we have seen, even if you use cutting edge, let's say GPUs underneath, maybe up to $30 an hour. But think about now Apache Hadoop servers in Vodafone again. In this example, I think that's important. You have 600 Apache Hadoop servers. They all have hardware that goes out of, let's say, out of technology forefront every 1 year, maybe every second year if you want. You can still, of course, do good things, but your hardware will be older and older and older. So you have to update the hardware, you have to get new hardware, there's some off time, you need to get the experts, you have to pay for the hardware, but also then all the development team around it, that is the administration, but also the installation, configuration of this Hadoop server, making it securely accessible in Vodafone. All of that, there's a lot things where you would think there's lots of work to be done, but Vodafone also has to pay. So of course, these big players, and you see Twitter is the same way, right? So they of course have to think about, this costs me so and so many money from hardware and people. I can go to the Google Cloud. I get even marketing indirectly out of it. So being a partner maybe of Google helps me to get better known. No, Vodafone and Twitter doesn't need that, right? But not many of you maybe know Pandora or Metro, right? So you see here that to others that are there, you see Pandora migrated 7 petabytes of data that they had to pay on their own in their own hardware infrastructure to the Google Cloud. Here we are talking about big data. And really to use this actively means also you need to update your hardware infrastructure regularly. So, and I can go on and go on. Lots of testimonials in these areas. Let us now come to some, again, other applications to make, again, the analogy to the building blocks of Lego. Here is a use case application from Twitter that was basically a little bit noted, and all of them are also available, so you can dive in them bigger. And I will not go through the whole application because each detailed description of this, of course, will fill a whole university lecture. But you see how nicely here the Kubernetes engine is then used, for instance, now thinking about what we just discussed, having a more specialized approach of using then a larger scale cluster where also HDFS comes. Remember now that this is here the Hadoop distributed file system, enabling as a cloud storage, a data flow, and all the BigQuery services that we already had. And by this, we have the whole, let's say, different lifecycle elements in it. We have different streaming. Remember that Twitter is about messages, right? And now Twitter is called X, I know, but many of the hardware probably has been very similar still. I don't know exactly, who knows what Elon Musk is doing with X now. The color changed, I know, the name has changed, so many things in the back probably changed as well. But it doesn't matter, it shows you still how nicely you could use it for such a use case, which is really then in the order of 200,000 messages per second. And this is something where the underlying infrastructure has to follow suit. So this is of course used for business, right? So advertising, so people get advertising their revenues out of it. You have track ad campaigns to basically be found, and this can be all very nicely do essentially with the Google Cloud Platform, and have they done, and of course gave good testimonials. And of course I was alluding a lot to Angry Birds, so we will have a short glimpse on that as well. It's very known. I don't want to explain anymore the kind of game. I think everybody know there are different ideas how you render it. Star Wars, I was already talking about. Rio, space, all have the underlying idea of course shooting birds through the sky. But the key message to take away is really here, nearly 60 million in gross bookings a full year, right? So it's one of the top 100 iOS games, Google's best play game. So they rised basically just in 6 months after its launch, right? Take this as a small startup idea. So in 6 months, you suddenly have, users in orders of magnitudes, and even ordering hardware that then follows users would be basically not possible in 6 months to, if you're very lucky, you get all your infrastructure sent immediately, and then having also everything installed, let's say in a couple of weeks, and then configured everything in a couple of weeks, you're hard, I think, to follow suit, because you also have to, of course, develop your game, scale your game. So it's really an interesting thing, which I like here to show you as a time issue that you have usually, right? No one says that you cannot do your own cluster downstairs. If there's time enough and you have money enough, you can do that. But still, in this critical 6 months, there was a time, let's say, window where Angry Birds now is it really working, right? Is it scaling? And if the users don't get their scalability and the game is boring and is not really working, fails all the time, then the people would not use it. And with this, maybe all the downstream, that even today, I think, there are basically movies around it. So all of that would not happen. So time to market is, so to speak, the term here a little bit also, where of course the clouds give you a significant advantage, again, compared to your own infrastructure that you have somewhere in the cellar. And that is something that you don't know. As I said, also think about the soccer game before from Angry Birds that failed. They maybe thought it would be a big thing. It didn't. And then they did the next game, Angry Birds. So maybe that works, but maybe it didn't. But worked and suddenly exploded in number of users. Things you can't know. And you have to have a robust infrastructure to really do this. And if you go into the elements more deeply, you see the same elements come back. The Memcache API that was already a Lego brick discussed many times in some of these, which is really a very smart way to have results to queries. And basically, you just come back to certain queries when you needed it the first time. So the beauty here is that queries are stored again and again, because sometimes in games like Angry Birds, many things are again and again the same, right? So you have the same, let's say, picks from how they move, how they walk around, and so on. So this is something that you can keep nice in the Memcache API, because in this level are many picks, so you don't need to go back to the original data source. So hence, lots of these Lego bricks you will find also that these big players have used in order to scale. The users API is another one. You see the task queues, and all of these are nicely these Lego bricks they use to pull together this game. Of course, the application logic itself, the idea that it's basically, you know, about birds and pigs and so on, is something they invented, they did. And there's lots of different elements and pieces where, you know, they also use then different elements of AWS. Basically, also, you see here, Angry Birds at AWS, right? So suddenly machine learning, for instance, is something where they thought more about the AWS services. So you don't, again, as a big player, then of course, then just using maybe one cloud and maybe use also other clouds as well, as we see in this example. It's very interesting to think about it. So please have a look more interested. I mean, if you're interested to do this, it's a very interesting, I think, success model of how clouds really work, this Angry Birds. Now, coming at the end of the lecture, just for you to several different Lego pieces where we would need, again, for each of these topics, much more. So we will cover, you know, AutoML techniques in lecture 13, the new one. But, you know, speech to text, text to speech, NLP, natural language processing that you see here, sentiment analysis, etc., what means, you know, is a language something positive or negative? You see a little bit the ideas here. Evaluate, is your product basically that you see, get maybe from a Twitter stream, you know, rather positive in the feedback from your customers or rather negative? This would be sentiment analysis. And you can nicely do this also with the Google Cloud here that you see. There's even AI infrastructures, again, deep learning models that you already know now. But this all field of language processing, which is a big topic, of course, for many products outside, is of course something which is also beautifully supported. Again, talking about this would fill easily a couple of lectures to really understand natural language processing, and today maybe even large language models that go be with it. You know, you all know ChatGPT, lots of things happened the last couple of years. But here I refer you to our NLP team at the university that has lots of these new elements, you know, for large language models in the curriculum. And then when you want to use it for your applications, think about that clouds like Google, for instance, have beautiful support with it, but also AWS, for instance, has also quite good support, and MS Azure. So solutions are there for a wide range of industries. I want to give that also to you as a kind of element that when you go to the market after the study, chances are that there are lots of good examples already out there why cloud computing has been transformed everything these days: healthcare, life sciences, manufacturing, supply chains, education. This is all fueled in one or another example by different cloud vendors. And here are examples again from the Google Cloud, which I would encourage you, if you go to the industry and thinking about that your boss says we need, you know, processing, maybe it's smarter to go to some of the cloud vendors. At the end, I would just also like to just give a short insight into a TPU. Again, the HPC course will make a more stronger analogy, just that you know that these Google Cloud Tensor Processing Units are very optimized for machine learning. By now, you know that what we do here in machine learning, for instance, in this convolutional network, is lots of matrix multiplications or matrix vector multiplications to get the weights right, to train the neural network. And this is very beautiful supported. So a tensor is nothing else than a multidimensional array, if you want, like this. And you shift this here through these different layers, learn from it, multiply it. You know, you have seen the convolution operation already in lecture 7. And for this, the TPU is just beautiful. And this is a Google technology that's quite interesting. So that's why I think it also should be having at least a short note what's happening there, because it's not NVIDIA, it's another vendor. However, you can't buy that. Also think about the different PAAS providers. They have all sometimes disadvantages in this. You know, we talked about this before. You basically are locked in many of these Lego bricks then to perhaps one provider. So the Lego is nice within one cloud, the Lego bricks, but when you want to combine it with others, you see here quite good overview, right, from the different ones you have. You're sometimes locked either in the languages or using, you know, elastic MapReduce or a specific type of MapReduce. So this is something which is maybe not so easy to do. And also, you know, when you have a NoSQL database, it's not so easy to combine that, for instance, with Oracle, right? That has a more Oracle database SQL approach with services. It's also what we discussed a little bit. You have here some advantages, however. I hope I brought across them in the whole lecture today, because PAAS is really a good solution if you want to develop your own application, even financially these days. Again, I'm not paid, of course, by Google, which I had here just as examples. And you see here, this video might be a good way of understanding, again, this development process and why, moving to PaaS clouds is a good idea. And that's all on the PaaS level today. Obviously, what we will hear the next time is basically then the software as a service model. So talk to you then.